All right, we're looking at now not only finding the line of best fit, but checking it for its residuals. Let's maybe first explain what residuals are. So let's say this is our scatter plot, and we decide that the line of best fit is this one. What residuals are is the errors between the actual value and the location on our line. So in other words, these points were all just slightly off of our line. But this is a good line of best fit, and so for a couple of reasons. One, we have small residual errors. In other words, everything is quite close to our line. That's one thing that's important. The second is we need some positive and some negative errors, some above the line and some below, because they kind of like cancel each other off then if that's the case. You want to match the correlation. In other words, this is a positive correlation and our line is positive. And you just want to be as close as you can to each of the points. And if you can go through some of the points, that's even better if that's a good line. So let's take a look at our example here. The line of best fit, I don't know exactly, but I feel like I want to go to -7 and 4. Let's see if I can find that. I feel like kind of if I use this point here and this point here, that I will create kind of the line I want to create. So as you know, let's create that line of best fit. We've done some practice on this. So this is -7 and 4. And the other point seems to be 5, 6, 7, and 10. And the first thing that we want to do is find the slope between those. And so I'm going to place 10 minus 4 and 7 subtract a -7. That comes out to 6/14. Now it's best to kind of get that as a decimal, I believe. 6 divided by 14 comes out to approximately 0.43. So that's our slope. The second thing we need is our intercept. So we're going to solve for the intercept. So we have an equation of a line. And you can pick any point you want to plug in. I'm going to use the positive values of 7 and 10. And so let's plug in there. So the 10 goes in, and 0.43 goes in, the 7 goes in. And then when we calculate that, 0.43 times 7 actually quite magically shows up to be 3. And so we get B equaling 7. What that means is our equation is y equals 0.43x plus 7. This is our equation of our line. The next thing we got to do is see how good that is as an approximation. So let's look at that. So the next part of the process is for us to compare our equation's answers to the original answers. And there's going to be some error between our line and what actually they were. Now that's what are called the residuals, the little bit of error. So our goal is to kind of fill in this table right here and then compare the original table values to it. So I'll do the first one, and then I'm going to just fill in some of the answers for time's sake. But what you do is you use your equation of 0.43 and then the x value of -4. Just to show you why I'm using -4, that's the same number that was used in the original point. And then a plus 7. And so when I do this calculation, 0.43 times -0.4 plus 7, I get a total of 5.28. So that is what I calculate. Now I put in the 5.28 here, and my residual, if I take 5 and subtract that, is 0.28. That's not a bad difference, right, between the original and the and my value. Now you'd go through each of these stages. Maybe let me try another one. Let's try the -2. So if I put in the -2, the value I get, 0.43 times -2 plus 7, I get 6.14. So I'm going to run out of space to write these. 6.14, 6.14. And then again, 7 minus 6.14 isn't that bad an error either. 6.14, let's see, is only a miss of 0.86. And again, you see what's happening is sometimes I'm missing kind of low. I'm missing on the low side, but sometimes I'm missing on the high side. And I would do the calculation for each of those to obtain the overall residual error. And the way you do that is you add up everybody in this column, and that's your overall error. Now, if it's close to 0, that's perfect, because that means you had some negative and some positive. You also want these numbers to be as tiny as you can. Maybe let me just do one more of them, and then I just want to show you how to plot these on a plot. Let me do a number that's later in the group, like let's say the 3. So let's multiply by 3 and then add 7. 0.43 times 3, add 7 to that. I get 8.29. 8.29. Now 8.29 isn't that bad as well. That's 0.71 on that side, and so on. Now the last thing is to so again you would calculate this. I don't have room or space to do that, but you would do those things. Let me show you how to graph this. So the final thing to do is then plot the residual graph. Now this isn't plotting the graph, it's the residual graph. And what that means is, like on a number system here, you're going to plot each of the errors. So like how much each of these missed by up here. So your plots are all, kind of close, and they will look like this because these kind of represent your positive and negative errors that you experience. So let me plot a couple of these guys. First, when I put in a -4, the error I found was just at negative 0.28. So I'm going to go to -4, which is right here, and I'm going to go down about negative 0.3. Now there are 5 increments here, so each increment's 0.2. So negative 0.28, I'm kind of guessing to be close to that. At -2, if you look at the -2 guy here, my overall error was 8.6. So if I go to -2, and then I go up 0.2, 0.4, 0.6, 0.86, my answer will be somewhere kind of in here. Each increment's like 0.2. And then I also did, what was the other one I did? I did out at 3, right? I did the calculation for 3. And at 3, my error was 0.71. So let's go to 3, 1, 2, 3, and then go up 0.2, 4, 6, 7 would be somewhere in there. And basically what I'm doing is I'm plotting the errors. I had a negative error, and then I had a positive error, then I had a positive error, and basically you plot each of those values to show the overall look. Now a couple things about that to tell you if things are going right. First of all, notice that the maximum value here is 2 and -2. That doesn't mean that your error can't be bigger than that, but your error should be kind of small like that. The other thing that should happen is that you should find that it has a fairly random look to it. If it ever formed a pattern, like a shape, like a curve or a parabola or something, it might hint that there was a better way to have done this. The other thing is that you should have some positive and some negative, and so this looks like a good little residual graph.